In this video, we're going to learn about partial derivatives. So first we're going to start with a two-variable function, f of xy. Then its first order partial derivatives are the functions f sub x of xy and f sub y of xy. And we have some alternate notation here. If we derive with respect to x, we might also use this symbol here, which looks like a curly D, and we call that partial of f with respect to x. Or if we derive with respect to y, then we call this the partial of f with respect to y. All right, now what does that mean, though? What does it mean to be a partial derivative? Well, we can think of taking the derivative of any one of the independent variables of a function. And what that means is that we're just taking the derivative of the function in that direction. So when we take a derivative in that direction, that means all other variables are constant. So that's what we do when we take a derivative, a partial derivative, is that we treat all of our other variables as constants. So here we're going to, in our first example, take this function of two variables, 4 minus x squared minus 2y squared, and we're going to find both of our first order partial derivatives of this function f. And let's do that. So we're going to do f sub x, and we're going to calculate what that is. Well, here we take the derivative with respect to x, and we treat every other variable as a constant. So what is the derivative of 4? 4 is a constant, so that is 0. What is the derivative of negative x squared with respect to x? Well, that is negative 2x. And then what is the derivative of negative 2y squared? Well, we're taking the derivative with respect to x. And so we treat y as a constant. So negative 2y squared is a constant, and the derivative of a constant is 0. So in fact, the partial derivative with respect to x is just negative 2x. We also have a first order partial with respect to y. So here 4 is a constant, so the derivative is 0. Negative x squared, well, we're taking the derivative with respect to y this time. So x is a constant, which means negative x squared is a constant, so the derivative of that is 0. And then the derivative of negative 2y squared is negative 4y. So the first order partial with respect to x is negative 2x, and the first order partial with respect to y is negative 4y. And that's it for partial derivatives. We're going to do several more examples, but that's essentially what is happening. You just treat every other variable as a constant and then take the derivative as normal. So for example 2 here, we are taking the, we're going to find the partial with respect to x evaluated at negative 1, 1. And then we're going to take the partial with respect to y and evaluate that at negative 1, 1. So we want the first order partial with respect to x. That's what we want to calculate first here. Oops. So we want to calculate that. Well, here we have y times (2x plus 3y) raised to the negative second power. So then we want to take the first order partial with respect to that. All right, y is a constant, so I just multiplied y times. And then we have, again, 2x plus 3y raised to the negative second. We want to take the derivative of that. Well, that is negative 2 times 2x plus 3y raised to the negative third power, all times And then we got to multiply by the derivative of the inside, right, where you're doing the chain rule here. But the derivative of the inside function is just 2 because we're taking the partial with respect to x. So the derivative of 2x is 2, and the derivative of 3y is 0. So we get f sub x is y times, or sorry, it's negative 4y squared all over 2x plus 3y cubed. And we want to evaluate this at negative 1, 1. So f sub x evaluated at negative 1, 1. We just plug in negative 1 and 1 in for those values. So we get to negative 4 times 1 squared all over 2 times negative 1 plus 3 times positive 1, all of that cubed. So this is negative 4 over 1 cubed, which is 1, so we get negative 4. All right, now let's do the same thing, but take the partial with respect to y. This one's a little bit more difficult. Let's rewrite this as y, this is f of x comma y, is equal to y times 1 over 2x plus 3y squared. Okay. So we notice that we should use our product rule when deriving here. So let's do f sub x, f sub y. So f sub y, we take the derivative using our product rule. So that is the derivative of the first with respect to y, which is 1. Times the second, so that is 1 over 2x plus 3y quantity squared, plus the first, which is y, times the derivative of the second with respect to y. Well, this is 2x plus 3y to the negative second power, so this is negative 2 times 2x plus 3y to the negative third power, times the derivative of the inside, which is 3. All right, and then we plug in negative 1 for x and 1 for y. So I'm going to skip down here and do that. So f sub y of negative 1 comma 1 is equal to 1 times 1 over 2 times 1 plus 3, oh, sorry, that's 2 times negative 1, plus 3 times 1, all quantity squared, plus 1 times negative 2 times this positive 3 is a negative 6, times 2 times negative 1 plus 3 times positive 1, all to the negative third. All right, 2 times negative 1 is negative 2. Plus 3 is positive 1. We got that squared. So this whole part here evaluates to be positive 1. And let's see, this chunk right here also evaluates to be 1 times negative 6. So we get 1 minus 6, which is negative 5. And that's it. So very last example here for this video, we're going to do all first order partial derivatives of w. But notice w has 3 independent variables now. So we are going to do the 3 first order partials. So let's take the first order partial with respect to x. All right. We're treating y and z as constants. So really, this is a constant times e raised to the power of x times some constant, right? Z times e to the y is just a constant since z and y are constants. Well, the derivative of that then is just the constant z times e raised to the same power all times the derivative of that exponent. Well, the exponent was x times z times e to the y, and the derivative of that with respect to x, the partial derivative of that with respect to x, is just z e to the y, because at x times a constant, the derivative of that is just a constant. And so that constant was z times e to the y. All right. So let's take the first order partial with respect to y now. And I'm calling this the function f again, and here we've used w, so maybe I should switch to using w. This is the function w, not f. So w sub y. So here we get z times, again, e to the x, z, e to the y. And then we need to multiply this by the derivative of the exponent with respect to y. So this is really times the partial derivative with respect to y of that exponent here. Well, what is the derivative of x times z times e to the y with respect to y? And in particular, what is the partial derivative with respect to y? Well, that's just x times z times e to the y, because x and z are constants, and the derivative of e to the y with respect to y is e to the y. So this all becomes z times e raised to the x, z, e to the y, times the partial of x, z, e to the y with respect to y, which is just itself. All right, and that is the partial of w with respect to y. Now we're going to take the partial with respect to z. Well, here we have the function z times the function e raised to the x times z times e to the y. So those are two functions of z. So we have to do our product rule here. So that is the derivative of the first times the second plus the first times the derivative of the second with respect to z. So that is ex z e to the y times the derivative of the exponent with respect to z. So that is just x e to the y. And that is exactly what we have written here. And that's it. We're going to have a second video where we talk more about partial derivatives. That's it for this video.